Hello everyone and welcome to Reading Code. This is my attempt to impart to folks my method for reading code. It's not the only possible method for reading code, but I've noticed that while there are a lot of programming tutorials about writing code, I don't know that I've ever actually seen one about reading code. So I'm just going to jump right into it here. What I've got in front of me is a project of my own. I wrote this some time ago. Not to toot my own horn here, it's actually a lot of crap code, but it was an educational endeavor for me, and I did it as I was gearing up for an interview. Most of my experience, especially recently, is with Java and with Apache Stack projects like Hadoop. I'm fairly comfortable reading that type of code, but if there's anything in which anybody is interested, then please mention it in the comments and I'll try to have a look. As we go in here, I'll just introduce you to my method for reading code. It's fairly routine and organized and pretty tedious once you get down to it, but hopefully it's pretty helpful. I've noticed that particularly when I start a new job or at my current job when I pick up a project that is well underway and to which I have no previous exposure, I can sometimes spend a week, maybe 2 weeks just reading code. It requires a lot of active reading, so I think that this is a skill that is not taught and is not well recognized or understood in the industry. I could be wrong about that, but please do let me know if this has been your experience, and I hope this helps. The first thing I'm going to do is mock a notepad. So I've got this whiteboard here, and the whiteboard is for your benefit for the sake of this video and this format, but when I'm doing this at my job, I'm using just a regular spiral bound notepad or similar. I'm going to divide the notepad into two sections here. You'll be using a couple of different pages, or maybe you'll use a notepad window for one section and an actual physical notepad for another, however works for you. One side is the to-do, or you might also interpret this as to read or to be traversed. The idea here is that we keep a list of concepts that have been mentioned but that we have not yet gone and read for ourselves, and gradually we build up this list and traverse the entirety of it. By the time we've created the entire list and completed the entire list, we should be pretty conversant in the code base that we're reading. The other page here is for actually writing down an interpretation of the code. This can be literally copying the code character for character, or it can be something a little less granular than that. I typically start off character by character just to get myself into the flow of the way in which the code is written, and then gradually, as that becomes more comfortable and easy to understand, I'll back out a little bit and become more abstract, less granular. Looking at this project, and it has been a while since I've looked at this project, there are a number of sections here inside the code. Now, the organization of this particular project might seem a little strange to some folks. Again, this was an educational project on my part, which I organized into several milestones. Typically in a Java project, you're going to see one source main Java and one source test Java folder. It's fine. It doesn't make too much of a difference so long as everything's in the build path. So we'll worry about one milestone at a time here and probably only just go through one section of the code. This method really does work best with code bases that have a lot of linkage. That is to say, classes or interfaces that are associated with each other and not a lot of just independent random stuff kicking around. So in this case, I'm going to check out the data structures work that I did. Now, this project was my attempt at understanding the Java collections utilities by implementing them against their declared interfaces in Java doc. These are not fully robust implementations, but they should serve the purpose of this video just fine. So notice how we're looking at a handful of source files, and these files seem to suggest that they are perhaps related to each other and certainly related to various data structures. So all of these things are going to end up on our to-do list. And there we are. So if you know anything about object-oriented programming, you know that these things are related to each other in a sense. They may have various dependencies on each other, and those dependencies comprise a graph. In fact, a directed acyclic graph. And this graph may be disjoint, or the pieces of it may be disjoint from one another. So really, in principle, we can kind of start anywhere picking one file, we might see that, say, a class implements a particular interface. If we see that, we probably just want to traverse right back to that interface to see where the whole thing begins. Or maybe not, depending on what we're trying to read and how much time we have to read it. So let's jump in. We'll start with collection here. And now that I'm looking at collection, I'm just going to go ahead and mark off that I've started to look at him. So collection is just an interface. It extends iterable, and it has some methods, very typical for an interface. So there isn't much to see here yet. Let's look at who this class extends. So we have an interface, and this is kind of a root interface. It does extend one of the Java Lang interfaces, not a big deal. So we're still in abstract land. We haven't gotten to any concrete implementation details just yet. If we want to go there, we can find out who implements this interface. And it looks like there are a handful of classes that implement collection. So let's just grab one. So we have array list implements list, and this looks like a pretty concrete implementation to me. So this is, I think, where I will start. Going through the class, I want to catalog the things that I need to know about the class, and in doing so, I kind of want to know the things that I need to know about the style in which the code was written, or the way that the developer was thinking when he or she wrote the code. So because I'm behaving as if I know nothing about this code base, I'm going to start documenting all of the member fields, the constants, things like that. And we can get started like that. Now, a note about both my penmanship and my abbreviations. For this method, and at least in terms of the way that I think and the way that I learn, my intention is rarely ever to go back to this page. In fact, usually I throw these notebooks away as soon as I'm done with them. I almost never go back and read them, except perhaps during the session in which I'm reading through those specific classes. The important thing for me is to actually write them down and engage with the material in some way. And engaging with the material in multiple ways, such as by reading it and writing it and attempting to interpret it, it reinforces my learning of the project at the cost of a few sheets of paper. So let's get these two constants up at the top. Notice at this point I'm being very granular in how I approach it, but I'm still abbreviating, leaving some things out. I know that these are constants because of the way that they look. And so in that sense, I'm already compressing the information that I attempt to convey to myself into the printed page and learning something about the style in which the code was written. So I'm engaging with the code style as well as the code content. Now moving on to the two member fields. And that's all the members. And don't worry about keeping this stuff too organized. I know that in a lot of open source projects or a lot of even closed source code that you'll encounter in your career, things are kind of scattered all over the place. So be it. So long as you're able to engage with the material and understand what's going on, that's fine. So we have a couple of constructors here. Let's just take them one at a time. So this constructor, we can see, calls another instance of the constructor that takes a single argument, which incidentally is the next constructor in the file. Now I'm going to start abbreviating constructor as CTOR. I've already seen one instance of a constructor, and so I have a sense of the style in which constructors are written by this developer. So I can start to use my own abbreviations in my own head and make this process a little bit faster. Notice how I didn't specify the type of the argument that is the input to this constructor. For most purposes, I kind of don't care. I can always look at it again, and if I have to modify it, I'll know exactly what's going on. I just need to know that it's there. So here's what I know now after having looked at and written down the contents of this constructor. It takes a single argument. That argument is the capacity of the array list. It initializes a store, which is just an array of the parameter type to the class, and it stores it just as an array of object set at a size of capacity. And initially the size of the array is 0, so it contains nothing. So this is just initializing an array. So we have a third and final constructor here. Here, because I'm interested in the interaction between these different classes, I am going to write down the type. And while I'm writing down the type, I know that this is a type that is not just a primitive type, it's an actual composite type or a class somewhere in the class hierarchy, and I know that I haven't seen it before, so I'm going to underline it. And at this point, I might underline it and go over here and check to see whether I've actually seen it before. And it looks like I have actually seen this before. Now I'm probably going to go back to this because it was an abstract implementation. There was no concrete code inside that class. I will probably go back to that a couple of times just to make sure that I understand the interface that it exposes and how it interacts with everything else. But I know that I've got an instance of it being passed into this constructor. So that's good to know. Fortunately, I've left myself some good comments here. That's not always the case. In fact, it's usually not the case. But looking at this, it's pretty plain to see that I know that I'm dealing with a class that's a collection. It's got an underlying array. So I already know something about how it behaves. And I have the good fortune of it being fairly simple and straightforward. It doesn't try to do too much. So my guess at this point is that because it's being passed in a collection, it's probably something like a copy constructor. It's taking the input argument and copying its contents, or making a deep copy perhaps, into a new instance that's being created with the call of the constructor. We can tell with the first line here that that's exactly what's happening. Typically when you see a pattern like other or obj or something along those lines, you're dealing with a copy constructor or something similar. Okay, now we're hitting our first loop block here. This loop, looking at the code, which I'll highlight here, pretty clearly, to me anyway, calls an iterator, loops through the iterator, obtains the objects from the other instance, and copies them over. Because I'm running out of room on the whiteboard here for the time being, but also because I have a good sense, having looked at it, of what's going on, and I've seen a lot of this repetitive context here that tells me a little bit about what's going on, I'm going to go ahead and gloss over this little section of code and just say iterate shallow copy of other. And now I have a pretty good idea of what's going on here, and I've written it down, so I've engaged with the material. I have a good sense of what I'm looking at, and I know what this is for, and I have a better idea of how these things interact. So I have a better sense of the context in which these things might be presented throughout the rest of the project. And so I'll keep going. Oh, and while I'm in here, let's just check that off so that we know that we're looking at or have looked at the ArrayList class. So we see that there's a method called size. This is pretty vanilla, pretty generic. I'm not going to worry too much about it, but I am, because it's the first time I've looked at an implementation of one of these classes. I'm going to at least make a note that it exists. Same with is empty. Contains is a little more interesting. Notice how it has a call to something else, to another method. So I am going to be a little more thorough there. I'm not going to worry about writing down the return type in this case because it's pretty obviously a predicate. The name of the method is very obviously a predicate. And again, that's all about engaging with and understanding the material. And I'm going to underline find an array. Now, if I had a notepad window open, I might actually go tap the enter key right here, and on an indent, insert, find in array. What I'm doing here is taking note of every time I see something that's unfamiliar but looks interesting to me. I know that I'm going to want to go and look at the find in array method to determine precisely what it does and how it interacts here. Now we've got add. And for purposes of this, and actually generally speaking, I'm not going to bother writing down all of the exceptions, the checked exceptions that are thrown by this method. There are going to be cases where I care about the checked exceptions that are being thrown out of a method, particularly if they are exceptions that are exclusive to the project, that is, exceptions that are specific to whatever it is that the developers are trying to accomplish within the project. And I would underline them and I would write them down in my to-do list, etc. It's pretty much the same pattern. In this case, all of these exceptions are exceptions that hang out inside of the java.lang package or namespace. So these are very familiar to me and I'm not going to worry about them for the time being. As an exercise to the audience, by all means, if you ever want to go and take a look at the JRE, I highly recommend it. And then you would be doing this exact same thing, but much more thoroughly than I'm doing right now, writing down checked exceptions and going and looking at them and seeing how they're implemented. It's all very interesting stuff. Here we go. Here's a new thing that we're going to want to look at, the grow store method, which takes no arguments. So looking at the add method, now that I've had an opportunity to write it down, what I'm seeing here is that first we're doing a boundary check. We're checking to see if the size of the underlying array or the backing data structure is too large to accommodate another element. We know that we're adding an element to the list here, and we know that this is an array list or a dynamic array. So in general, the dynamic array is implemented such that you start with a fairly small sized array, and every time you need to exceed the boundaries of that array, you grow that array by something like double its current size. Over time, that amortizes out reasonably well, so you pay a little bit of a tax ahead of time to copy all of the elements from your current location to a new location. But basically, because you're doubling with each addition beyond the current size of the array, it ends up being pretty cheap in the long run. And we'll keep going here. And we'll turn a page in our notepad. And look at the remove method. So first we start with some bounds checking. So here's another abbreviation that I will tend to do. Again, if I'm not terribly worried about the exceptions that are being thrown out of a method, I'll just sort of indicate here that I'm throwing something. It doesn't really matter what it is that I'm throwing. I just know that I'm throwing. Also, now that I've had a chance to look at a couple of these methods, I know that in the style of the code, I can probably expect to see things like bounds checking up at the front or up at the top of a method. I can also expect to see fairly organized, even kind of anal code blocking like this. Notice this else is not strictly speaking necessary. Being the guy who wrote the code, I happen to know that there's a reason that I use blocks like that, but again, it's a stylistic thing and a lot of things could be correct in this place. The indentation style of the code might be a little bit longhand for some folks, particularly in Java, and that's okay. It makes it easier for me to read. In the future, when I look at some other projects, I'll try to take on some projects that are written in code styles that are opaque, and we'll see how that goes and how that's different. So we're going to initialize a Boolean here. So this is a pretty complex block, starting to see a lot of repeating patterns. and I'm going to have to turn the page here, so I'll erase the board shortly. But basically, what I think I'm looking at are some checks in the remove method to see whether the element in question is null. So it looks as if this collection, this array list, will actually support inserting and removing null valued elements, which is cool. That's a nice feature to have. And we noticed in the blocks above that there was a shift variable that was being set to true in some instances, that defaults to false, but was being set to true if it looks like we're going to remove an element. And that gets evaluated here. Where it looks like we take the next element in the array and bring it down to the location of the current element. And same there. And we finally bail out. After having traversed the entirety of the array, the assumption being that if we've found what we're looking for in the array, but we've made it all the way to the end of the array before we found it, then it's the last element in the array. Otherwise, it's somewhere in the middle of the array, and we have to iterate through the rest of the array, shifting all elements down in order to bring everything back into position with the missing element being removed, or the element to remove being removed. And so that handles the final case, where the element to remove is the last element in the array. And then in keeping with the interface, we return whether we actually had to remove an element or not. And let's go ahead and turn the page. And this is another method, the Iterator method here. We're just going to note that it exists. It just returns an iterator. There is something interesting here, actually, now that I'm looking at it again in more detail. Look at this array list iterator here. I'm going to change my mind. I want to know what array list iterator is. And so I'm probably going to add it over here. An add method that takes an index and an element to add. Starts off with some bounds checking. I know I've already underlined this elsewhere, but I'm going to underline it again because I haven't seen it yet. This looks like it's handling the case where the desired index of the element is at the end of the array, in which case we just put it there. Otherwise, we have to insert the element into the desired index inside of the array and then shift everything back one space. And looking at this code, I know that that's what it's doing, so I'm going to kind of gloss over it here. And then increase the size, and that's it. And a method get. Looking at this method, we can see that it does some bounds checking and throws. I'm not going to worry about that. Again, I can kind of just assume that this is the case, and if I need to know it, I can always look back at this code to find out what I need to retain is what it actually does as its primary effect. Happy path, which returns an element in the backing array. And a set, which takes an index, element value. Again, this does some bounds checking, not too worried about it. But looking at it, it looks like it actually returns the element that may have been removed from that index in the backing array. So I'll make a note of that. And so I kind of care about this, the fact that it returns a value of type T, which is the type that's stored in the array list. And remove, which just takes an index. And it seems to have the same contract, the same interface that the set method does, which is that if an element has been removed from that position, it returns that element. This looks like it's handling the case where the index is at the very end of the array. We toss away our reference. And then shift everything else in the array down. And then return the previous value, if any was stored there. Now we have an index of, and we care about this a little bit because it calls this method that we have not yet seen. Now we get to our grow store. If you remember, we've seen grow store a couple of times now being called by other methods, but we have not actually read through the method yet. And because generics in Java get a little unwieldy, we have to do some kind of strange things to deal with it. So I'm creating a new array of object. What I'm really doing here is creating a new array of the current length of the store times whatever the growth factor is, which defaults to 2. And set the store to be the new store. And that is how this code is growing the dynamic array. And now we come to find an array, which wants an element and whether apparently to search backwards. Now looking at this, find an array is asking for a plain object type, and then we take it and actually derive or cast it to whatever the type parameter of the class is. And that's again to get around some of the oddities of Java generics. Here, it looks like we are trying to set the direction of traversal. I take that back. It looks like we're trying to set the origin of traversal based upon whether we've been asked for a backwards or forwards traversal. Looking at this while condition, it looks to be the case that, yeah, this is where we account for the actual traversal. So what it's kind of saying here is if we're going backwards and element I is greater than or equal to 0, or if we're not going backwards and element I is lesser than the size of the array or the maximum index stored in the array, then we keep going. Otherwise, we drop out. So I'm just going to kind of gloss over that bit and make a note to myself and move on. Okay, so what it looks like we just did there in this section of code right here, again, this array list supports null objects. So the first thing it does is checks to see whether the element that has been asked for in the find an array inputs is null. If that element is null, and if the element at the ith location in the store array is also null, then we can safely return the fact that we found the object. On the other hand, if it's not null, if instead the ith element of the store array is equal to the object that's been passed in, and equality is being assessed in 2 different ways here. Either it's the same object, which is what you get with the equals equals there, or it is built such that it can be tested for equality in a different way, and that equality turns out to be true, then we can return the index into the array. After that, we do this if backwards check here, and we do something like increment I else decrement I. And if we didn't find anything at all, we return -1, which looks like it's a return value that indicates that nothing was found inside of the array for the element that was asked for. Okay. Here we come to the ArrayList iterator. Now this is a class, it's a nested class inside of the ArrayList class. This is a pretty typical pattern and it's not a huge deal, but notice how we had it over here. This is something that we actually cared about and we wanted to see in the future. We've seen this. Now we're gonna look at this. And I might care about and want to look at Iterator. I know that it's on my list right here. So I'm going to underline that just to reinforce in my mind that that's something that I want to see. And we basically just repeat the same process. So we have a reference to a backing array, a reference to the size of the array, an index, a constructor, which just kind of sets some stuff. And because this is very vanilla, and because I'm becoming comfortable with this code, that's all I'm going to write. It's got a has next, which tells a caller whether there's a subsequent element in the array. So this is going to start out with a bounds check. This is actually a pretty important bounds check. I'm not going to worry too much about documenting it. I'm going to be glad when I read it that it exists. And if I'm reading through code like this and I don't see a bounds check on here, I'm going to have a problem with that code. We'll just get the salient bits here on the happy path. Fairly classic linear iterator here. Nothing too special here. And then there's a remove, which is clearly marked as an override here. If you know anything about Java, you know that this annotation, the override annotation, means that it overrides something. That something is probably inside of this iterator interface right here. It implements it and then fails to actually do anything with it. And that, I happen to recall at the moment, is because I didn't want to at the time. So be it. And that's it. Now we have taken a look at the ArrayList class. We cross it off our list, cross this, cross this. If I had bothered to write grow array down on that list, I would have crossed that off as well. And there's another thing on here that I care about, which of course is the fact that this implements list. So I might want to take a look at that. And again, we're getting into abstract stuff here, but now that we've actually gone through and read through a concrete implementation of this interface, we can kind of take a look at what we're seeing in terms of the methods that a list is supposed to implement and understand a little bit better about how this might be placed in context, which then allows us to go back and look at collection again and see the same thing. These are more abstract interfaces. Each one is a specialization of these concepts. So list implements collection, collection implements iterable, and iterable just gives us an iterator. And we've already marked off a pretty big chunk of our list. An iterator, we now know because we've looked at implementations of it, gives us has next and next. And there we are. That's as far as I'm going to go for this video. If you want to take a look at the code yourself, I will leave a link in the description. I'm sure that there are errors that I missed and other problems that you can find with the code. So by all means, dig through it and find what you can. When I go through a project like this, as you can tell, this is actually pretty time consuming. And it seems like if you're in a situation where you have to understand what's going on and make a code change very quickly, you may not have the time to do something like this. And often that might be the case. But if you have the time and if you can make an argument on behalf of being able to get the time, you should. Whenever you're encountering a code base, particularly one that you have to work with for a living, one that puts food in your belly and clothes on your back, it's important to understand what's going on, and it's important to just have the skill of being able to dig and understand what it is that you're working with. This is a very important skill. I can't stress that enough. So although it seems tedious and boring, it's very important to be able to do this. If you'd like to see more of these, I'd be happy to do them. I'd also be happy to do some streaming ones where you get to see the outtakes and errors and other tedium of the process in real time. Let me know in the comments what you think, and if this helps you, I'd love to hear about it. I'd certainly love to hear about any projects that you're able to take a look at having mastered this skill. So good luck, take care, Forever out.